In this video, we're going to talk about two kind of minor topics in the idea of conics, but very helpful, especially to graphing with the first topic. So first of all, I want to define what's called the latus rectum. It is a chord through the focus, so the dotted lines here, that connects both sides of the ellipse, and it's perpendicular to the major axis. There's also that similar chord in a hyperbola or a parabola. But we're going to start with just talking about the ellipse. So here we have an ellipse. Here's the equation, x squared over a squared plus y squared over b squared equals 1. So it's centered at the origin. We go out to a0 and back to negative a0. That distance from center out is a. The distance from the center up to the top is b. The distance from the center to the focus is c. So that's where all these coordinates of these points are coming from. Now, when you draw an ellipse, just using the four vertices, it's hard to know kind of how round to make it at the ends. We tend to make it a little too pointed. So it's really helpful to have like just a couple of extra points to help us draw it more accurately. So if we were looking at this little chord that goes through the focus, we know then that the x coordinate of this point is going to be the same as the x coordinate of the focus. It'll be c. But what would the y coordinate be? Well, it turns out it's going to be b squared over a every single time. And I'm going to show you this with an example just to show you how it works, and then go back. Well, actually, let's just talk about why it's b squared over a, and then we'll go look at an example. So let's say here I'm looking at this drawing here, and I'm going to let x equal c in my equation, and then figure out what y would have to be. So if I put c in for x, this would be c squared over a squared plus y squared over b squared equals 1. Secondly, then, I know that c squared equals a squared minus b squared based on the Pythagorean theorem, and you know what we had here. Here's my b and my c and my a. So I can substitute a squared minus b squared for c squared in the equation. That leads to the next equation, a squared over a squared minus b squared over a squared plus y squared over b squared equals 1. Well, a squared over a squared just equals 1, so now I have a 1 on both sides of the equation, which I can subtract off on both sides, and so that leaves me with this equation now. Negative b squared over a squared plus y squared over b squared equals 0. I add b squared over a squared to both sides, and that leaves me with a simple ratio, and then multiplying both sides by b squared, I would end up with y squared equals b to the fourth over a squared. And then when I take the square root of both sides, y equals b squared over a. So that means no matter what c is that I put, like in any particular ellipse that I use, the y value, if x is c, is going to be b squared over a. Similarly, if the ellipse is going the other way, so that the latus rectum links here, like in this example, are horizontal lines, and my y value is the value for the focus, c, then my x coordinate would be b squared over a. And this also turns out to be true for hyperbolas. So let's see how this works in a particular example. This is the ellipse x squared over 9 plus y squared over 25 equals 1. We go out plus or minus 3 in the x direction because of the 9, and we go up plus or minus 5 in the y direction because of the 25. The focus goes on the y-axis because it is the longer axis. That's always the criteria for an ellipse. I know that the distance to the focus is the square root of 25 minus 9, a squared minus b squared, which is 4. So I plotted the two foci right here and here. So if I draw a chord through the focus perpendicular to the major axis, its endpoints will be right here and here, and those endpoints have the same y coordinate as the focus. So 4 and 4 here, negative 4 and negative 4 here. So if I were to plug 4 into the equation for x and solve it for y, I would end up getting plus or minus 9/5. And that would be true whether or not y was positive or negative 4 because I'm squaring it. All right, so you can try solving it yourself. I'm not going to go through that right now. I'm just going to tell you that it always ends up being b squared over a. Now, b squared is the smaller value in an ellipse. The b is the smaller value, and the larger value is the a. So I use the b squared, 9, and then a would be the square root of that number over 5. So that's 1.8. That means the distance from here to here is 1.8. Okay, so this distance is 1.8. And this distance is 1.8. So this would be 1.84. This would be negative 1.84. This would also be 1.8 and negative 1.8 for negative 4. This gives me 4 more points so that when I draw the ellipse, I have 8 points to use instead of 4, and that makes it a lot easier to draw an accurate value for the ellipse. Okay, so I'm looking at all of these 8 points that I can use to draw my ellipse. So this is really helpful, and I'm going to also show how to use this for the hyperbola in the next video. Now the second topic, the second minor topic here, is the term eccentricity. Eccentricity is a value that measures the roundness of the ellipse, and it is just the c over a, which is the distance from the center to the focus divided by the center to the vertex on the major axis in the ellipse and the only vertex in the hyperbola. So notice in an ellipse, the focus is inside the ellipse, so c is always going to be less than a. So when I do c divided by a, I'm going to get a number between 0 and 1. If e actually equals 0, it's a circle, because that means the distance to, that means the c, the distance to the focus, is actually 0. In other words, there is no focus, it's just right on the center. As e gets, so if e is close to 0, the ellipse is more circular. As e gets closer and closer to 1, we have the ellipse being more elongated. In the example above, c is 4 and a is 5, so the eccentricity is 0.8, which means it's rather elongated as ellipses go. Not terribly elongated, but more elongated than it is round. Now when e actually equals 1, meaning c and a are the same value, it turns out that that figure then turns into a parabola at that point. And if e is greater than 1, it means that the distance to the focus is greater than the distance to the vertex. That happens in a hyperbola. So anything where e is greater than 1, the figure is a hyperbola. So that's the meaning of eccentricity.